Alright guys, so I want to do one that kind of touched on one that was like number 13 and number 14 too actually, and it's kind of an expected amount, and we didn't really look at any of these in the during the chapter, but it was kind of, we can sort of figure out how this works, and I want to walk us through one of these. So number 13 says this, that there's a factory that makes crackers, and the factory has an 8% defect rate. That means that for every 100 crackers they make, 8 of them on average is defective, so a cracker doesn't come out exactly right. So out of every 100 crackers, 8 of them are messed up in some way. So what they told us here is that they took a sample of 500 crackers. The inspector came by and picked out 500 random crackers that were made that day, and we want to see, okay, if they have a defect rate of 8%, then how many crackers in that sample would we expect to be messed up, right? And then also give or take how many. It's not going to be exactly that 8%. It might be a little more, a little less, because we saw from sampling, from like rolling the die, that just because there's 8% defect rate doesn't mean that our sample is going to have exactly 8% things messed up. So we're going to figure out how many we expect to see, and then give or take how many, all right? So we expect how many crackers defective, and give or take how many. So the expect how many crackers defective, that's easy. All we have to do is we do 500 times 8%. So 500 times 0.8. And whatever we get when we do that, that'll give us how many crackers we expect to be defective. So if we come down here, we do 500 times 0.08, we multiply that out. Let me check real fast, make sure I get it right. Times 0.08, and I got 40. So 40. We would expect 40 crackers to be defective. That's the easy part. Now the give or take part gets a little bit confusing, but so the give or take, for the first step for the give or take is we have to find the standard error. All right, and the standard error, if you remember, it was p times 1 minus p divided by n, square root the whole thing. In this case, P is our population proportion, so our 8%. So we're going to do 0.08 times 1 minus P, so 1 minus 0.08 would be 0.92. Got to be careful of these. Remember, these two, the way to check these should add up to 1. So if you do 0.08 plus 0.92, that would add up to 1 right there. It's like 8%, and then the rest of it would be the other 92%. There's 92% of crackers that are good, but only 8% that are messed up. And then divide by n. N is the number of the size of the sample, so that would be 500, and then square root the whole thing. So I want to kind of show you my calculator as I'm doing these calculations, so we see what's happening. So let's see what we got here. So I'm going to do 0.08 times 0.93, and I get that. Oh, 0.92, sorry. 0.08 times 0.92, I get this. And then divided by 500, and I get this 1.42 something, whatever, e to the minus 4. So remember, that's scientific notation. So then I want to find the square root of this, so I'm going to say second square root. And then I'm going to go down here to the bottom where it says, in the blue, it says answer right there on the minus sign. And I'm going to say second answer, and that's going to plug in the previous answer right there. So square root of that answer equals this. So I get this number. I'm going to round it off to, let's do 4 places. 4 places works out pretty good. So what do I get? I get 0.0121. There we go. So 0.0121. Nearest, what's that? Tens, hundreds, thousands, 10,000s. Nearest 10,000. That's pretty good. All right. So that's my standard error. So why did I find that? Over here, it was 500 times the P, essentially, because this is like the P. To find the expected number of crackers, to find the give or take, we do 500 times the standard error, and that'll give us the give or take. Alright, so we would do 500 times this right here, 0.0121. And what do we get? So we do 500 times 0.0121, and I got 6.05, and we'll round to the nearest whole cracker. So we'll round it to 6. So this will be 6. So what would we expect? We would expect 40, give or take, or plus or minus 6. That's how many crackers we would expect to find defective. Okay, so we would expect 40, give or take 6. And I kind of like writing it like this because then it kind of looks like a range a little bit. We could even go a step further and say if we did 40 minus 6, that'd be 34. And we did 40 plus 6, that'd be 46. So we would expect somewhere between 34 and 46 crackers to be defective if there was an 8% defect rate on that 500 cracker sample. Okay, so hopefully that kind of clears some things up for 13 and 14, and then let's keep on going with something else.